Good morning. This is frequently asked homework questions from homework 3.11. So we're going to start off with problem number 7. So you might want to take a second to read that. And I've already done a little bit of work to make sure that the video doesn't last too long here. So you can, of course, pause as you need to. So what we have going on here is we have 2 containers, and we're pouring them together to make 2 solutions. So first, and I've kind of just drawn diagrams here, we have 300 milliliters in a container, and we have 600 milliliters in the container. We are pouring those together, which of course would mean we have 900 milliliters. And we are being given that of that 900 milliliters, 15% of it is acid. Now again, you're not going to see, if you were to look at this container, you're not going to see, oh, right there's the acid and here's everything else, but I'm going to demonstrate that in just a second. So again, 100 is the total solution. 15% acid, so we can actually calculate how much acid would be in this container. So 135 milliliters. And so, again, that's like the acid. So we'll say that's the acid. Well, now where did that acid come from? Well, some of it came from here, and some of it came from here. So we know a total. We know that there's 135 milliliters of acid in all. So we have to think about where that came from, and we'll come back to that in just a second. So then it says we've got the same 2 containers. We have 100 of the first, 500 of the second. That gives us 600 milliliters in all. The problem then tells us that of that 600 milliliters, 12.5% of it is acid. So once again, we can figure out how much acid is in this final mixture. So again, it's 75. So there's the acid. And some comes from here, some comes from here. So let's keep reading. It says, what's the concentration? So what we are actually finding here is we don't know the percent of acid in container 1. And we'll let Y be the percent of acid in container 2. So if I go back to my problem, I don't know how much acid is in it. I don't know how much acid is in it. That's what I'm trying to find. But I think we can write an equation. I know 135 is the total amount of acid. Well, if container 1 has 300 milliliters and X is the percent of acid, if I wanted to write an expression that represents how much acid is in it, I do what I did here. I took 15% times 900. So I'm going to do the same thing here. I'm going to take 300, or excuse me, I said 900. 900. I'm going to take the 300 milliliters and multiply it by the percent of acid. For container 2, I would take 600 milliliters and multiply it by how much acid. Okay, same thing at the bottom. The total amount of acid in the second mixture is 75 milliliters. That 75 milliliters comes from some of it being in mixture 1 and some of it being in mixture 2. Let you solve that, but when you do, you find X to be 0.25 and Y to be 0.1. So mixture 1 is 25% acid, while mixture 2 is 10% acid. Is what you got going on there. All right, the next question we're looking at is number 8, and so here's a couple things that I've already done on number 8. The first car leaves and travels 45 miles per hour, so I know its rate. And I decided that since we don't know how long car 1 is traveling, I just called it T. The second car starts half an hour later. So here's what you need to think about. If car 1 has traveled 1 hour, car 2 will have traveled half an hour, t minus 1/2. If car 1 has traveled 2 hours, that means to get the time car 2, I would take 2 minus 1/2, and its speed is 55. So then the question is, how long will it take the second car to catch up to the first? And so what that implies, if they're leaving from the same place and they are meeting each other, they've caught up to each other, that means they've traveled the same distance. So I'm really looking for, where has the distance of car 1 become the same distance as car 2? Well, to find distance, you do rate times time. Distance equals rate times time. So that would be rate times time and rate times time. And so you would just solve this equation then. And so when I did that, I got 2 hours, 2.75 hours. And so if you want to make sure you're writing that, that's the time after car 1 has left. So it takes 2.75 hours after car 1 leaves for car 2 to catch it. You could also say that it takes 2.25 hours from the time car 2 leaves to catch car 1. That would be fine as well. And then there's B part. It says, will that be in time? Will that be before you get to the game? So really, this is where that 135 miles comes into play. And so all I really need to do is see what that distance is. So I'm going to take 45 and multiply it by the time. That would give me the distance, which is 123.75. So that's when they will meet each other. They meet each other 123.75 miles after the start of their trip. So yes, they do meet before the location of the football game. All right, so as I look at number 1, and we have worked a couple of age problems. So I did one in the last video, I believe. A movie star, unwilling to give his age, posed a riddle. 7 years ago, I was 11 times as old as my daughter. I am now 4 times as old as she is. So let's work with this now. So if you know the movie star's age, you would take the daughter's age and multiply it by 4. So therefore, the movie star is 4 times as old as the daughter. The next thing says 7 years ago. Well, actually, you would need to take the movie star's age and subtract 7. You would also need to take the daughter's age and subtract 7. And in 7 years ago, the movie star was 11 times as old as the daughter. So you would take that daughter's age and multiply it by 11. And that's the setup for that problem. So a few of you asked about number 9. So as I'm looking at number 9, it asks you how much was invested in each type of tree. So I let X be the money invested in dogwood trees and Y be the money invested in maple trees. And the very first sentence gives you how much money you invested in all. And so there's one of your 2 equations. From there, it's talking about profit. Okay. So it says that you have a total for profit. It says that you make 20% of your stock. So you're going to make 20% of your $40,000, your total investment. Now, how do you make that 20%? Well, for every X, for every dollar of X, you've made 25% off your dogwood trees, and you've made 17% off your maple trees. Okay, so your first sentence here is about your total investment, and your second sentence here, or equation here, is all about profit. And the other thing that we don't know here is we don't know the total amount invested. So let's go back and read. We've invested $4,000. We're investing an additional amount. We don't know what that is. So we don't know our total. So again, this equation is all about your total investment. Now, your other equation is how much money you earn off those investments. Well, it tells us that our first account earns 4%. So we're going to earn 4% of 4,000. So I can figure out how much money I've earned off that account. Account 2 earns 5.5%. So if I wanted to figure out or write an expression for how much money I've made off that account, I would take 0.055 times X. And my total amount, I earn 0.045 of my total investment. So there's your equation for that.